Okay, if you've joined us, we are looking at Year 11 trigonometry, Year 11 Maths Advanced, I should say, trigonometry. And we'll look at some proofs, some basic proofs to start off with. You need to really know this kind of identities first. And that is 1 minus sine squared x is cos squared x. 1 minus cos squared x is sine squared x. Sec squared x minus tan squared x equals 1. Cosec squared x minus cot squared x equals 1. So let's just start with that basic things first. There's a few more identities, but you need to know this first. So from that, for example, they can make you this. So just say the first one, for 1 minus sine squared x equals cos squared x. You also have to know difference between squares as well. You know how 1 minus sine squared is really 1 minus sine x, 1 plus sine x. So I'm reverse engineering this, by the way. So if you take this to this side and one of these over to the other side, meaning that if you keep this side over here and take one of the cos down that way, and then you keep the cos over there and then you bring that down, that's one thing they have you asked to prove. So you are proving this, for example, right? So this looks damn hard, but really it came from this, if you think about it. But how do you actually prove that? If they ask you to prove that, well, if you're given, this is how you prove, by the way, left-hand side equals 1 plus sine x over cos x. You need to write exactly what left-hand side is. You can't write a simplification on left side. Whatever left-hand side is, write exactly that. Then the right-hand side tells you what to do. The only thing you can do to that is you can difference for two squares. So you multiply top and bottom by 1 minus sine x would introduce the 1 minus sine x on the bottom on the right-hand side. Yeah, because whatever you multiply on top, you're going to multiply by the bottom. So the top will give you then difference of two squares, which is 1 minus sine squared x. The bottom you have cos x outside of 1 minus sine x. But then 1 minus sine squared, you know, is cos squared x divided by cos x, 1 minus sine x. So cos squared divided by cos, and there's one cos remains. So then you end up with essentially what is the right-hand side. Voila, right? So what looks so complicated here really is not that complicated, and it came from that anyway. Yeah. So the key about trig is you should know the difference between squares. That's one simple trick. You really have to know the identities, really. And the third one is you have to know further identities, which I will show you in the second example. So that was example number 1. Here's example number 2. All right. So that's DP number 11 again. So eg2, trick proofs. This is. So we'll take the same example. We'll take the same one. So 1 minus sine squared x equals cos squared x. Factorize that out again. Yeah. This time, I'm going to simply change this one into 1 over sec squared x. Because as you know, sec squared is 1 over cos squared. Or 1 over cos sec squared is cos squared. You have to know that. So that's a property, right? So again, if you were to take 1 sec up there, left 1 sec down here, you will end up with sec x, and I'll choose to keep the plus, and then I'll take the other one over to the other side. So sec squared goes up there, and then I'll keep 1 over this side, so I have 1 over sec x, and I'll take the minus over here. So I'll take one sec over there. I'll take this one down here. Yeah. I'll leave this one here and I'll take one of the sec up there. So that's a question. Prove that that is that. So it looks hard, but really it's not hard. So anyway, let's start. And that's where it came from, basically. So you start with sec x, 1 plus sine x. Now, I mean, there's many ways of doing this, by the way. There's not one way. But you can see the right-hand side tells you what to do. If you're going to have a sec 1 minus sine on the bottom there, then that's what you're going to do. You multiply by the 1 minus on the bottom. Or you multiply by sec. It doesn't matter. Yeah? So let's say you multiply by that. So that's the left-hand side. You have to leave that. So you go sec x then, 1 plus sine x, multiply by 1 minus sine x, 1 minus sine x, to introduce the 1 minus sine x. Whatever you multiply by the bottom, you have to multiply by the top, because that's essentially 1. So the top-hand side will give you a difference of two squares, which is 1 minus sine squared x. The bottom is 1 minus sine x. But 1 minus sine squared, as you know, is cos squared x. The bottom is still 1 minus sine x. But then what happens when you multiply a sec x with a cos x? So you strip out one of the the cos squared. Sorry, that's not right. So I made a boo-boo there. So that's, you split cos squared into a cos times a cos, because sec times cos is really 1. Right? And so you end up with then really cos x over 1 minus sine x. So you're almost there. But you don't want cos, you want sec on the bottom. But cos is really 1 over sec x. And when you divide by a fraction, you divide by, when you have a 1 over sine, that goes down the bottom. So that means it's sec x, then 1 minus sine x, which is really the right-hand side. So the theory there, by the way, is 1 over a over b is really 1 over ab. That's a basic algebra rule that you have to know, that you must know. But that's basically the example of trig proofs. That's how you do proofs for trig. It looks complicated, but the right-hand side tells you kind of what to do. All right, now I'll stop there.